Good morning. In this video, we are going to study the topic virtualization in SDN for BTech exam students by MegaGirl. So let us start. So this is the PDF I've already shared by the name Lecture 1 of Network Virtualization by Daniel A. Menace. What he says is virtualization was involved 30 years ago. Why did he invent it? To allow large expensive mainframes to be shared. That means we want to share one computer among very large number of environments. So we want less number of investment. Means we want less cost, investment and greater benefits of storage, computation, etc. So virtualization is all about sharing systems, storage and network. But as in when the computers became less expensive, virtualization used to gradually drop, but now it has risen again. So what is system virtualization? System virtualization, what it does is, it adds a hardware abstraction layer which is known as virtual machine monitor VMM on top of the hardware. So let's see, where is it? This is your system. In this you have the VMM added just above the hardware. So this is the first rule for virtualization, that is we add the virtual machine monitor. Okay, we added it. Now what does this layer do? This layer will handle all the hardwares, the virtual machines. The virtual machines will simply be running in their different regular operating systems. Each virtual machine may have its own different operating system, not necessarily have the same operating system, which would normally run directly on top of the actual hardware. Now the main motivation was to increase the level of sharing and utilization of expensive computing resources such as the mainframes. That is how virtualization evolved. Now let us see next. Large number of client machines connected to numerous servers of various types give rise to computation paradigms such as client server and peer-to-peer systems. This is how this originated. But these terms also brought some kind of challenges like reliability, security, then cost, complexity, floor space, etc., power consumption, thermal dissipation. Now, the recent rebirth of virtualization techniques is posed to address these problems in a very elegant manner. What are the basic concepts in virtualization? We will see this. Basic concepts in virtualization means that we have consider a production environment consisting of a batch jobs and online transactions that run on top of transaction processing monitor. Developers need to test the features. So testing is to be done. A typical approach is to use one machine for production environment and one for testing. But what we will do here is we will do production and testing both using the virtual machine. We will not isolate these two jobs. So we have the testing environment, production environment, and below that the virtual machine monitor and the hardware to do it. So in a virtual machine environment, what happens is virtual machine monitor VMM runs in supervisor mode and controls access to the resources shared by all virtual machines, and the virtual machines run in user mode. Why user mode? In user mode you cannot use the privilege instructions. So what are the two types of instructions? We will come to it later, but just now we can just know that the virtual machines usually run in the user mode. Okay, this is another diagram of virtual machine. Now comes the advantage of virtual machines. Advantage of virtual machines is security by compartmentalizing environments with different security requirements in different machines, one can select the guest operating system and tools that are more appropriate for each environment. Reliability and availability. A software failure in a virtual machine does not affect other virtual machines. Cost. It is possible to achieve cost reductions by smaller servers. Adaptability, workload variations. Changes in workload intensity can be taken care of by shifting resources and priority allocations. Next is load balancing. Since the software state of an entire virtual machine is in VMM, it is easy to migrate virtual machines to other platforms. Legacy applications. Even if an organization decides to migrate to different operating system, it is possible to continue to run legally applications on the OS running on guest operating system within the virtual machine. The next thing here comes is that what is the performance modeling? So performance modeling के लिए हम लोग use करते हैं QN model, which is the analytical queuing model. Analytic queuing model में हमने क्या किया? It is composed of resources. So resource क्या है? Queue है, which may be of three types. ये जो queue है ये three types की है. Load independent, where the service rate does not depend on the queue length. इससे हमें कोई फर्क नहीं पड़ता कितने लोग हैं एक इंसान को प्रोसेस करने के लिए हमको कितना टाइम लगा. That is independent of the number of people standing in the queue. This is load independent. The second is load dependent. जितने लोग हैं उसके according आपको सर्विस मिलेगी. That is load dependent. And delay resources, that is there is no queuing. The unit of work that flows through a queuing is generally called a customer. A queuing model can have more than one class of customers. Now, the workload intensity of an open class R is defined by average arrival rate lambda R. Okay. The workload intensity of a closed class R is specified as concurrency level NR of the class, that is the number of concurrent customers of the class in the system. QN model works with both open and closed system, which is the mixed QN model. So we compute DIR. DIR is the service demand of customers class R at resource I, and workload intensity levels per class, arrival rates or concurrency levels. Service demand is DIR. DIR क्या होता है? Total service time of customers of class R at resource I. So DIR की वैल्यू क्या होती है? UIR divided by XOR, where UIR क्या है? UIR is the utilization of resource IE by class R customer, and XOR क्या है? XOR is the throughput of class R customers. तो ये वैल्यू आपने कंप्यूट कर दी DIR की. Okay. And the last thing, that is the concluding remarks. Concluding remarks बोलते हैं कि बहुत सारे vendors है like Sun, IBM, Intel, which have started developing virtualized solutions. Intel has just announced an architecture which is known as Intel Virtualization Technology that provides hardware support for virtualization. And Sun has introduced the concept of zones in Solaris 10, which allows for many Solaris 10 instances to coexist on the same machine. It is important to briefly discuss two major directions for virtualizations that can be encountered in the market. One is full virtualization and another is para virtualization. दोनों में डिफरेंस क्या है? फुल एंड पैरा के अंदर. फुल के अंदर VMM provides an identical abstraction of the underlying hardware to the virtual machines. However, not all architectures are virtualizable. So, in para virtualization, let's say a virtual machine is not able to become virtualizable, then some guest operating system will be added so that we can make the guest operating system will be modified so that virtualization can be encompassed for that particular machine. This is para virtualization, and the performance of para virtualization is better than virtualization because in para virtualization the guest operating system already is aware that they are running on a virtual machine, and therefore they can be optimized for that type of environment. And the example of them are, para virtualization is Zen and Denali. So this is your topic. Virtualization, we will see if we'll get some more resources. We can discuss some more of it also. By now, I think you must have got what is virtualization, how do we get it by virtual machine manager, VAM layer, virtual machine monitor, VMM layer, and what does it help in? It helps in the sharing of resources, reduced cost, reliability, availability, adaptability, load balancing,